From factory floor to air supremacy, this is the Su-57 Felon. Mach 2. Super cruise capable. 7,000 to 6,000 pounds of combat power. A fighter jet, which is invisible to radar. From raw titanium to air supremacy.
Welcome to Russia's most advanced aerospace facility, where we transform raw titanium and carbon into the Su-57 fighter jet.
Titanium billets arrive for the Su-57's airframe structure.
Furnaces heat titanium to 950 degrees Celsius. 75,000 tons forge critical structural frames. Each component requires multiple precision forging stages. Controlled cooling ensures optimal titanium material properties.
5-axis CNC machines cut titanium to exact dimensions.
Coordinate measuring verifies accuracy to 1 micron tolerance. Verified titanium frames await fighter jet assembly integration. Carbon fiber prepreg stays frozen until layup begins.
Automated cutters shape each composite ply precisely.
Robotic tape layers build wing skins automatically. Vacuum bagging prepares composites for autoclave curing. Massive autoclaves cure multiple components simultaneously. Laser projection guides technicians placing each ply exactly. 6-hour cure cycles reach 180 degrees Celsius.
Cured composites emerge strong and perfectly formed.
Every composite part undergoes rigorous non-destructive testing. Ultrasonic scanning detects any internal composite defects. Digital X-ray reveals bond quality and hidden structures. Thermal imaging exposes delaminations invisible to other methods.
Certified inspectors analyze every scan for flight safety.
Laser shearography finds defects in honeycomb core structures. Traditional tap testing still validates composite integrity.
Approved composites proceed to fighter assembly lines.
Massive jigs align fuselage sections with laser precision. Titanium frames lock into position within hundredths millimeters. Friction stir welding joins aluminum without melting material.
Electron beam welds titanium inside protective vacuum chambers.
Skin panels attach with thousands of precision fasteners.
Internal structures support all aircraft systems routing. The audio contains a voiceover that says, "Forward fuselage reveals the Su-57's stealth design philosophy."
Multiple fuselage sections advance toward final mating.
Su-57's advanced wing design begins taking shape here. Carbon fiber spars carry immense flight loads efficiently. Leading Edge integrates high-lift devices and stealth features. Massive wing skins integrate with internal rib structure. Trailing edge surfaces provide roll control and lift augmentation. Internal wing tanks undergo rigorous fuel sealing process. Hardpoints enable external weapons and fuel tank carriage. Completed wings await final mating with fuselage. The Su-57's advanced tail section enables extreme maneuverability. All moving stabilators enable 9G maneuvering capability. Tonum. Redundant actuators ensure flight control system reliability. Canted vertical stabilizers reduce radar cross-section significantly.
Tail stinger houses rear warning radar for threat detection.
Tail booms house engines in wide-spaced stealth configuration. Control surfaces undergo precise rigging and alignment checks. Completed empennage defines the Su-57's agile character. Saturn's AL-41F1 engines power the Su-57 fighter. Single crystal blades survive 1600-degree temperatures.
Precision grinding creates perfect blade root attachment geometry.
Powder metallurgy discs resist extreme rotational stresses. Compressor blisks achieve 14:1 pressure ratio. Advanced combustors achieve efficient, high-temperature combustion. Core assemble joins compressor, combustor, and turbine sections. Completed cores await afterburner and nozzle installation. Afterburner section adds 15,000 pounds extra thrust. Three-dimensional vectoring nozzles enable post-stall maneuvering. Nozzle vectoring tests verify 15-degree deflection range.
Accessory gearbox powers all critical aircraft systems.
Complete AL-41F1 ready for acceptance testing procedures. Engines enter enclosed test cells for acceptance runs. Tested engines shipped to aircraft final assembly line. Full afterburner test confirms 32,000 pounds thrust. Engines enter enclosed test cells for acceptance runs.
Internal weapons bays maintain the Su-57's stealth signature.
Bay doors open in under 1 second for deployment.
Smart weapon interfaces require extensive secure wiring.
Ejector racks ensure positive weapon separation at speed.
Ejector racks ensure positive weapon separation at speed.
Door cycling tests verify sub-second operation times. Side bays carry close-range air-to-air missiles internally.
Completed bays integrate 6 internal weapon stations.
Conductive edge seals maintain radar signature integrity. The Su-57 cockpit integrates advanced glass displays.
Ejection seat rails enable rapid emergency extraction.
The K-36D5 seat enables 0-0 pilot ejection.
Dual touchscreen displays present all mission information. HOTAS controls keep pilot hands on flight controls. Holographic HUD provides critical flight data at eye level. Life support systems sustain pilots at extreme altitudes.
Completed cockpit awaits fuselage integration and testing.
Avionics integration occurs in secure cleanroom environments.
Triple redundant computers ensure flight control system reliability.
Fiber optic networks transmit data at gigabit speeds.
Mission computers fuse sensor data for pilot awareness.
Flight control laws undergo rigorous software verification.
Integrated avionics pass comprehensive systems communication tests. Inertial navigation provides GPS-independent positioning capability. Electronic warfare systems provide self-protection capabilities. The Shesh-121 radar system sees threats in all directions. Thousands of T-R modules form the active array.
Internal weapons bays maintain the Su-57's stealth signature.
Side bays carry close-range air-to-air missiles internally.
Completed bays integrate 6 internal weapon stations.
Conductive edge seals maintain radar signature integrity. The Su-57 cockpit integrates advanced glass displays.
Ejection seat rails enable rapid emergency extraction.
The K-36D5 seat enables 0-0 pilot ejection.
Main radar array installs behind the nose radome.
Stealth coatings absorb enemy radar energy invisibly.
Multiple RAM layers achieve optimal radar absorption.
Controlled curing develops optimal coating properties.
Edge treatments eliminate radar reflections from panel gaps. Controlled curing develops optimal coating properties.
Radar cross-section testing verifies stealth coating effectiveness.
Coating thickness verification ensures consistent radar absorption.
Stealth coating complete, the Su-57 becomes nearly invisible. Landing gear withstands extreme touchdown impact forces.
Carbon brakes provide high-energy stopping performance.
Oleo struts absorb landing energy through hydraulic damping. Main gear mounts into reinforced fuselage structure. Nose gear steering enables precise ground maneuvering. Retraction testing verifies complete gear cycling operation. Gear doors seal flush for aerodynamic stealth performance. Complete landing gear, ready for ground operations testing.
Final assembly brings all major components together.
Wing mating requires laser precision structural alignment. All ground systems verified and certified, ready for engine testing.
Test pilot performs simulated startup with auxiliary power unit running.
Internal weapons bay doors cycle through opening and closing sequences.
Electronic warfare systems respond to simulated threat emitter signals.
The Su-57 moves to the engine run-up testing facility.
Reinforced tie-down cables secure aircraft for full thrust testing.
Test pilot completes pre-start checklist and seals the canopy.
Left AL-41 F1 engine, ENTS ignites and spirals to idle thrust.
Both engines advance to maximum military power without afterburner. Full afterburner unleashes over 30,000 kilograms of total thrust.
Taxi tests verify steering, braking, and ground handling performance.
Taxi test complete.
Taxi testing complete. The Su-57 is cleared for first flight.
When the Su-57 launches, enemies have seconds to live.
Supercruise at Mach 1.6. No afterburner required.
And that is how we build the Su-57 Phelon fighter jet.